Hello everyone, welcome back to my channel Gemsofknowledge. So in my today's video we are going to solve with the model paper for the class 9, that is science subject. Okay, so before starting my video, make sure to subscribe to my channel and also click on the bell button to get the notification as soon as I post my new video. So this is the model paper which is given by the board. Okay, you can see here Karnataka School Examination and Assessment Board. Okay, so this is from the board paper. So today we are going to solve that paper. So let's quickly start with the video. So you can see here the first part A is physics part. So in today's video we are going to deal with the physics part. So in my upcoming videos I'll also share the chemistry as well as the biology part. Okay, so here you can see 4 alternatives are given for each of the following question or incomplete statements. Choose the correct alternative and write the complete answer along with the correct option. Okay, so let us choose over here. So the first question is SI unit of force is. So we all know that SI unit of force is nothing but Newton. Okay, so what you need to do here is you need to write the option number C and you need to write this Newton over here. Okay, next, the value of acceleration due to gravity of Earth is. So we all know that acceleration due to gravity value is 9.8 meter per second square. So the second answer is also C, that is 9.8 meter per second square. You can also write this like this or you can mention it with a minus sign also. Okay, next, the audible range of sound in human is. So basically the audible range of sound in human is 20 hertz to 20,000 hertz. Okay, so that is 20 hertz to 20,000 hertz. So here the answer is A1, that is A, 20 hertz to 20,000 hertz. Okay, so this is the multiple choice which is given in the physics part. Let's quickly move on to the question answers, that is the next part. Okay, so the fourth one is the weight of an object on earth is 36 Newton. They have already told us that weight of the object on the earth is 36 Newton. What would be its weight when measured on the surface of the moon? So on the earth, if the object is 36 Newton, then we must find its weight on moon. Okay, so we all you can see here the solution is done. Okay, weight of an object on earth is 36 Newton. We all know this because this is present into the question itself. Weight of the object on the earth is 36 Newton. What we need to find? Weight of the object on moon we need to find. Okay, so we are having one formula which is present in your textbook, that is weight of the object on moon will be 1 by 6 times its weight on the earth. So this is the formula which is present into the gravitation chapter. Okay, so directly we can write 1 by 6 into, here we are having 36. So 6, this is 6 ones are 6 and 6 6 are 36. So that is 6 Newton. 1 into 6 is 6 Newton we got. So weight is measured in Newton. Okay, so we'll move on to the next question. Okay, second question, suggest a method to decrease reverberation. Okay, so we need to suggest a method to decrease the reverberation. Okay, so we all know what is reverberation. It is excessive amount of what we can say sound which is produced in the big halls or auditoriums or theaters and all. Okay, that is just because of the regular repeated reflections what is occurring. We can say multiple times reflection is taking place of the sound, so we get reverberation. Okay, so they are asking us the method to decrease reverberation. To reduce reverberation, the roofs and walls of the auditorium are generally covered with sound absorbent material. So we need to cover that auditorium or that particular hall with the sound absorbent material like compressed fiber boards. We can use fiber boards, rough plaster or curtains, heavy curtains or similar to this. Okay, so this is one of the method to decrease reverberation. Another material we are using for the seats as well. Seats material are also selected on the basis of their sound absorbent properties. Okay, so the material of that particular seat is also selected on the basis of their sound absorbent properties. Okay, so you can see the next question. Answer the following question is given. The motion of two motor vehicles. Okay, so there is the motion of two motor vehicles are given in the graph A and B. it is shown in the figure as graph A and graph B. So they are asking which graph is showing the reach of 20 kilometers in shortest time and why. So just observe the graph. We have to answer which of this graph is showing us 20 kilometers in shortest time. Okay, so just you can see this is the graph for uniform motion and this is the graph for non-uniform motion. So this graph shows us, see, this is time on x-axis and on the y-axis they have taken distance in kilometers. Similarly here, time on x-axis and distance in kilometer in the y-axis. Okay, so here you can see 5 minutes 5 kilometer, 10 minutes you can see here this is 10 kilometers, 15 minutes 15 kilometers, 20 minutes and 20 kilometers. So according to this graph, for 20 kilometer to travel 20 kilometers we are taking 20 minutes. Okay, now according to the graph B, you can see 5 minutes they are covering 2 kilometers. Then on the 10 minutes, for the 10 minutes they are covering nearly 8 or 9 kilometers. Then for the 15 kilometers they are 15 minutes they are covering 20 kilometers. You can see this point. Okay, and this point comes somewhere here. So this is within 15 minutes they are covering 20 kilometers. Here we are taking 20 minutes, here we are taking 15 minutes. So what is the shortest time? For non-uniform graph we are taking shortest time. Okay, so what we are going to write with the answer? Graph B shows the reach of 20 kilometers in shortest time. This graph shows us the reach of 20 kilometers in very short time because it is non-uniform graph. Okay, and it shows non-variation of distance with time, means there is no exactly variation with of distances with time. Here you can see exactly 5 minutes 5 kilometer, 10 minutes 10 kilometer, because this is uniform. This is not uniform, so however time passes it can increase its speed or it can increase its distances according to that particular thing. Okay, whereas the graph A shows equal distances in equal interval of time, hence graph A is uniform graph. Okay, so this graph A is uniform graph and this graph B is non-uniform graph. Since it is non-uniform, it shows variation in its time as well as distances. Okay, so I hope this is clear. We'll move on to the next one. Okay, next question is define kinetic energy and potential energy. We know the difference between both. What is kinetic energy? What is potential energy? So kinetic energy is the energy possessed by a body due to its motion. When any of the object is moving, any of the body in the sense object, when the object is in its motion, means when it is moving, it possesses kinetic energy. Okay, similarly when the potential energy possessed by a body due to its position, when a particular body or when a particular object is kept to a certain height, then it contains potential energy. Okay, so position in the sense to some extent we can say to some height. Okay, then only we can say it is potential energy. Okay, next question is what is an echo? What is the minimum distance to hear an echo? So you know what is echo. Okay, that is the process or we can say the phenomenon of hearing back our own sound after multiple reflection. After many times reflection taking place, we can say that we can hear our own sound repeatedly. We can say 3 times, 4 times, 7 times. Okay, so that process or that phenomenon is known as echo. What is the minimum distance to hear an echo? So to make anything echo, we should have the minimum distance as 17.2 meter. So the minimum distance between us must be 17.2 meter. There is no maximum distance. Maximum distance it can be anything. Okay, so minimum distance must be 17.2 meter. If your room is lesser than that 17.2 meter, then there will be no echo in that particular case. Okay, next, draw or sketch a distance time graph of a moving bus with the help of the following data. Now you have to draw a distance time graph depending on these 3 situations. A bus travel in uniform motion. So you came to know that the graph is uniform, means how the uniform will be. Uniform graph you all have seen in the previous question. Okay, means it must be a straight line. It will be a linear graph. Okay, no bending, nothing. It will be a linear graph, straight graph. Okay, Next, they have given us the option. It reaches a distance of 20 kilometers in 40 minutes. See the points, they have given 20 kilometers in 40 minutes and 80 minutes. It takes 80 minutes to travel a distance of 40 kilometer. So this is the points which we need to plot onto the graph sheet. Okay. So here the space is given to draw the graph. As you can see, on the x-axis you are going to take time, and on the y-axis you are going to take the distance. So this is distance time graph. Okay. Then just see here, they have given distance always it will be in kilometers and time always it will be in minutes. Okay, so just see the minutes, they have given us 40 minutes and 80 minutes. Okay, so just an example, we got 40 minutes and 80 minutes. We can even take 40 and 80 only, but what we will do is we will take from 10, 20, 30, 40, 50, 60, 70 and 80. Up to 80 we need it, so we have drawn up to 80 minutes. Here you can see distance, they have given 20 kilometers and 40 kilometers. Even we can draw only 2 points, but what we have done is we are going through these points. Okay, that is 10 kilometer, 20, 30, 40, 50 and 60. Now let us plot the points. They have told us 20 kilometers in 40 minutes. So this is the kilometer, 20 kilometers and 40 minutes. So your point will be somewhere here. Next, 80 minutes. 80 minutes means minutes is here. 80 minutes and 40 kilometers. So 40 kilometer is here and this is 80 minutes. So this particular sketch is your distance time graph for the given question. Okay, we'll move on to the next. Okay, the next question you can see, a car falls off a ledge. Falls off means, this shows us falls off means free fall. Okay, so this question is related to the free fall, and drops to the ground in 1 second. 1 second is given, it means time they have given. Let g is equals to be 10 meter per second square. So g value they have given, that is acceleration due to gravity, that is 10 meter per second square. So we need to calculate three things over here. What is its speed on striking the ground? What is its average speed during the 1 second? And how high is the ledge from the ground? So first thing what we need to do here is we need to write what is given into the question. So first we know that time is given. Time t is equals to 1 second. And initial velocity, just see the starting velocity, it is falling off, means at the initial it is at stop, means the velocity is 0. So initial velocity u is equals to 0 meter per second. 0 meter per second. Okay, then g is already given, acceleration due to gravity, that is 10 meter per second square, already given into the question. Okay, and then acceleration of a car, just see acceleration of a car, a will be equals to plus 10 meter per second square. Same thing, but we need to add here plus because it is free fall. Free fall is falling in the downward direction. If you are keeping something to the height and it is falling down, means it is falling towards the earth, towards the ground. If it is falling towards the ground, then we can say that the gravity is in positive direction. Okay, means everything whatever we are if a ball is thrown in the upward direction, okay, that is against the gravitational force, then it will come the minus sign we have to put. Okay, now this car is falling from a height, means it is falling to the ground, which is in the direction of gravity itself. Okay, so this is plus 10 meter per second square. So the first one, what is its speed on striking the ground? So we need to find the speed v. We are having the formula v is equals to at. Okay, so substitute a value is plus 10 into t value is 1 second, that is 1. So 10 into 1 is 10 meter per second. So v speed is calculated in meter per second. Second question, what is its average speed during 1 second? In 1 second, what is its average speed? So we are having the formula average speed is equals to u plus v divided by 2. Initial velocity we are having 0, that is 0 we got, plus then we got the speed, that is 10, substitute, divided by 2 as it is. So 0 plus 10 is 10 itself. So we are getting, this is 2 ones are and 2 5s are 10. So 5 meter per second. So this is average speed. Okay. Then the last one, how high is the ledge from the ground? So we need to find the height over here. Okay, how high they have given. So we need to find the height. Height in the sense here we can find out the distance traveled. What is the distance from top to bottom of that particular thing? So we are having, according to the three formulas of the motion, we are having one last formula here, that is S is equals to ut plus half at square. Okay, so let us substitute the value. U is 0, t is 1, plus half will be as it is, into a is 10, and t square means 1 square, time. T is time, 1 square. Okay, so 0 into 1 is 0 itself, plus this is half, into 10 into 1 is 10 itself. So this is 2 ones are 2 fives are. So we are getting 0 plus 5. 0 plus 5 is 5 meter. So the distance traveled or height, whatever we can take, is 5 meter. Okay, let's move to the next. Okay, the ship of a nation drowned in a deep sea. Okay, now the ship is drowned into a deep sea. To detect this sunken ship, another ship sent to that place. Then, okay, now one more ship is sent to that place to identify that sunken ship. Now name the device used to detect the sunken ship. So what device we can use here is sonar. Sonar is the device used to detect the sunken ship. Next, write the abbreviation of that device. So we are having the abbreviation for that device, that is sound sonar. SONAR. SO stands for sound, N stands for navigation, A stands for and R stands for ranging. So sonar means sound, navigation and ranging. Okay, now we need to write how it works and explain. We need to explain how this sonar is working. Okay, now the sonar consists of transmitter and a detector. Now this sonar consists of two important things. One is transmitter and another is detector. Okay, the transmitter produces and transmits ultrasonic waves. So this transmitter, what it does, its work is to produce and transmit the ultrasonic waves. These waves travel through water, and after striking the object on the seabed, that is seabed means deep inside the sea, after striking the object inside that seabed, what it does is it's reflected back and it is sensed by the detector. Whatever the waves are reflected back, this transmitter, whatever it is reflecting back, that is detected by the detector. Now the work of the detector start, that is now the detector converts ultrasonic waves, that waves is converted to electrical signals. When and the distance of the object which reflected sound waves are calculated by knowing the speed of the sound in water and time interval between transmission and reception of the ultrasound. Now for example, if this is a ship, okay, and deep inside the seabed, here you can find any object, suppose we can say a big stone. Okay, so what this transmitter does, it sends the ultrasonic waves, it produces and transmits the ultrasonic waves. These ultrasonic waves, when it falls on this particular thing, okay, what it does is it gets reflected back. Okay, when that ultrasonic waves are falling on this particular stone, then that it is reflecting back the rays. Okay, that rays which is reflecting back is taken up by the detector and it will convert it into electrical signals. Okay, now this reflected ray is taken up by the detector and it will convert that ray into electrical signals. Okay, now later on what happens, after getting signals, what happens, the distance of that particular object from that ship is known. Okay, so after getting the particular electrical signals, what we are doing is we are calculating the distance of the object. Okay, this object is how far from that particular ship or boat, whatever it is. Okay, then how it is calculated, by knowing the speed of sound in water, how far away that particular stone is, and the time interval. Speed, what is the speed, and the time interval. By knowing these two things, that particularly we can find out how far that particular stone or whatever we are searching for is from that particular ship. Okay, so this is how your sonar is work. Next question is, an object of mass 15 kg is at certain height from above the ground. Now mass of the object is given, that is 15 kg, and it is above the ground. If the potential energy of the object is 450 joules, find the height at which the object is with respect to the ground. G is equals to 10 meter per second square. Now the into the question only they have mentioned as mass of the object m is equals to 15 kg, as you can see, and potential energy they have told us, that is 450 joules. Okay, and one more hint they have given us, that is G is equals to 10 meter per second square. Okay, now we know the formula that potential energy is equals to mgh. So potential energy value is 450, which is equals to mass is 15 into g we got, that is 10, and into height we need to find out the value for the height. Okay, now what we will do is we will keep this 450 as it is. We will bring this 15 into 10 to this side. If when we are bringing this to this side, this multiplication will change into division, so that it will become h is equals to 450 divided by 15 into 10. Now this 0 and this 0 is cancelled. We are left with 45 by 15. So 15 ones are 15 threes are 45. So this is 3 meter. Okay. Okay, next question you can see, state Newton's 3 laws of motion and give an example for third law of motion. They are asking us all the 3 laws of motion and they need the example for the third law of motion. So the first law of motion, an object continues to be in a state of rest or in uniform motion along a straight line until and unless an unbalanced force is acting upon. Means whenever a body is moving, if suppose this body is moving, unless and until I stop this pencil to move, it is continuously moving into the state of motion. Okay, this law states this. Okay, or if this pencil is kept as it is, okay, as it is, unless and until I move it, it won't be moving. So this is what your first law of motion says. Okay, then second law of motion, the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. So change of momentum is only possible when you apply some unbalanced force. Okay, so the change of momentum is directly proportional to the unbalanced force. Means F is equals to mass into acceleration. That is your second law of motion. Okay, then third law of motion, to every action there is an equal and opposite reaction. Whatever action we do, we get an equal and opposite reaction. This is your third law of motion. So the example for your third law of motion is, when a sailor jumps out of the rowing boat, when the moving boat is there, okay, when a boat is moving and that particular sailor jumps from that boat, then the sailor jumps forward and that boat will move backward direction. So this is just an example for your third law of motion, that is, to every action there is equal and opposite reaction. Okay, so this is the end of physics part. So in the next video I'll be dealing with the chemistry part. Okay, so don't forget to like and subscribe to my channel. I'll be back soon with the next part of this video. So till then, stay tuned and stay connected. Thank you.